Okay, first thing I want to let you know of is that I did post a review package in Google Classroom for you, okay, because obviously your unit exam is a week from today, so you can have a look at that over the weekend. Okay, it's also the last couple of pages that are in your Kinematics workbook. Okay, so if you printed that, it's the same thing. Okay, I did include a key, so you can check your answers as you go. Okay, but I'd suggest having a look at that. Some of the stuff on that review sheet, especially near the end of it, are kind of beyond what I would ask on an exam. Okay, so if you're getting to that and you're going, oh, I had no idea how to do this, yeah, the last few are just there to humble you a little bit, in case you're getting a little bit cocky about how good you are at all this stuff. So just know that that's there. You need to start preparing for that because it's now, like I say, only a week away. I'm not taking anything else in, okay, for the rest of this unit, so you won't have any assignments or anything like that to do for me before the exam, so that you have time to prepare for the exam on the 10th. Now, my idea here is that we're done Unit 1 today. Okay, we don't need to do any more stuff. Okay, in Unit 1, we're going to do projectile motion stuff today, and that'll be it. Friday, quiz on projectile motion. Monday, I'll do a formal unit exam review, and you'll get whatever is left in class to ask questions, work on some things. And then Tuesday, we'll be starting dynamics. Okay, so Tuesday and Wednesday, okay, will be Unit 2. That stuff won't be on the Unit 1 exam, because it's from Unit 2. And so it won't be on that. Okay, questions on that? All right. So the worksheet that we were working on yesterday, okay, I've picked some different questions from that I want you to work on here. Okay, and those questions are 3 and 5. Those are the two horizontal ones I want you to try. 12, 13, 14, and 15. Those are the angled ones that I want you to try. We'll go through each one of those, okay? Give you a few minutes, and then we'll do one together. Give you another few minutes and do another one, okay? And we'll see how that goes, okay? And of course, we'll break it up with a few more dumb physics videos, okay? Yeah. Okay, so if we're looking at number 3, we got an object that's thrown horizontally at 18 meters per second from the top of a cliff. So there's our cliff, okay? It's thrown at 18 meters per second horizontally, so I'm just going to make my horizontal information go here and my vertical information go here. Okay, it says the object hits the ground 100 meters from the base of the cliff. Okay, so when it does this, this distance is 100 meters. Okay, we're looking for how high is the cliff. I can't even do that bracket thing today. It's been a struggle. Okay, we're looking for the height of this cliff. So we're looking for the vertical displacement. We know the vertical acceleration is 9.81 meters per second squared. I'm not going to make it negative here. Why not? Everything's going down. It doesn't change direction, so there's no need to make it negative in this situation. Okay, and what's the other thing I know vertically? Right, and it's what? 0. It's 0. Okay, so VI is 0 meters per second. Okay, so if I'm looking for how high the cliff is, I really need one more piece of information, and that would be what? Time. I need time. Now I can get it with the horizontal information because I know both the velocity and the displacement. All right, so I'm just going to go V equals d over t and manipulate for t going 100 over 18. All right, so we're looking at 5.5 repeating seconds. That number can come over here with the vertical stuff, and I can use it in this formula. D equals VI times T plus 1/2 AT squared. So that'll be 0 there. So 1/2 times 9.81 times 5.5 squared. Okay, so the cliff is 151 meters to 3 significant digits. All right, questions on number 3? How many people have done number 5? Okay, do we want to go over number 5, or do you want more time on 5? Okay, let's look at 5 then. Nobody wants more time on it? Okay, so on this one, okay, still something thrown off of a cliff, thrown horizontally at 20 meters per second. Right, obviously it's going to do this. In this question, we're looking for how far from the base of the cliff it hits. Okay, we know the time, 4.20 seconds. Okay, how far from the base of the cliff, right, did it hit the ground? Why is this question ridiculously easy? Yeah, I gave you the horizontal velocity and I gave you the horizontal time. Well, actually the time for either one of them. You have to do anything vertical in this question? Once in a while I throw one like that at you just because. Okay? Because people look at it and go, it can't be that easy. Critter's not that nice. Can't possibly be that easy. Sometimes it is. Okay? So on this question here, if you were overthinking it, all it was d equals v times t. You didn't have to do anything else. Okay? And just multiply those numbers together. So 20 times 4.2, 84.0 meters. All right, I'll give you a few more minutes on 12 and 13 here, and then we'll have a look at those. Okay, so on this one, we got the object, and it's on the ground. It's projected at an angle of 35 degrees. Okay, and the object is in the air for 9.26 seconds. Okay, at what velocity was it thrown? So I'm looking for this. Now we did one that was like this once before, but I gave you a little bit more information than I do with this one. Okay, so I don't have any horizontal information other than time, but I do have a little bit more information vertically. Okay, vertically, I know obviously the time because they gave it to me, and I know the acceleration. Since we're not told otherwise, can we assume that the launch and impact are level? What does that mean for VI and VF? They're the same. Well, one's negative and the other's positive, but they're the same magnitude. So, just like we did with the one the other day, okay, you got VF minus VI over T, but if these are the same number, all we have to do is take out the F and the I and go negative V minus V, because they're the same number. All I have to do is put a negative vector on the first one. That means that this formula is now negative 2V over T, and I can now manipulate to get the initial vertical velocity, which will give me the final vertical velocity as well. All right, so I'm going to multiply both sides by T, and then divide both sides by negative 2, and that will give me V. So that'll be 9.26 seconds times negative 9.81 divided by negative 2. All right, so we are looking at an initial velocity here of 45.42. So that's that side. Since I have one side and the angle, can I get all the other sides of the triangle that I want? I only want one side of the triangle, and it's I want the hypotenuse. Yeah. Okay, so I've got the opposite side and the angle, and I want to get the hypotenuse. So sine of 35 equals 45.42 divided by the hypotenuse. So all I have to do is manipulate this, okay, in order to get the hypotenuse by itself. So the hypotenuse will be 45.42 divided by the sine of 35. Okay, so this thing's projected velocity is 79.2 meters per second at 35 degrees above the horizontal. Okay? Arlen, looking at it funny. Did I lose you somewhere? Sorry, you're just giving it kind of the side eye.
Oh,
No?
okay.
Okay. All right, any other questions on that one? Okay. All right, keep going. I'll give you a few minutes on 13, 14, and 15 there. Put them back up on the board. Come on, that's the thing. So for number 13 here, we got this object thrown into from the ground into the air at 15 meters per second. So this is the 15.7 meters per second. What we don't know is the angle that it is thrown in. So I've got one side of the triangle. I'm looking for the angle, which means I need at least one other side of the triangle. Agreed? Okay. So we know the object travels 25 meters horizontally. And we know that it was in the air for 2.15 seconds. What can I find with that?
The velocity horizontal.
Right, I can find the velocity horizontal, which is always this side of that projected triangle. Right, so I'm going to solve for v horizontal by just going d over t, 25 divided by 2.15. Okay, so 11.62 meters per, or 63 meters per second. All right, now I know two sides of the triangle. I know the adjacent side and the hypotenuse. So I'm just going to go that the angle will be the inverse cos of the adjacent side, 11.63 divided by 15.7, and when I do that, I should get 42.2 degrees above the horizontal. Okay. Questions on that one? How are we doing on 14 and 15? Anybody done all the way past 15? Okay. No, keep going. I'll give you a few more minutes and we'll look at 14. Yep. Yeah, if you do it in 2 steps,
Okay.
use another formula to find VF,
Okay.
then find K.
Alright.
Yeah?
Yes.
Yes, and that's negative,
Okay.
right?
Yeah.
This will get out.
Yeah.
That's the trick with that question.
Unless if acceleration isn't negative.
Yeah, you can do that too. If you make the acceleration positive, then they're fine, as long as they're both the same vector. Yeah. It is. That's. Yep. It's already moving down. So this isn't true.
That's for,
Well, that's for 14.
yeah, just two.
Yeah.
Yeah, now I don't know if I got it wrong.
And it's actually, there's actually 2 steps, because the first formula you think to use is the one I told you never have to use to solve for t. So you actually have to find t, or find VF, and then find t. Oh, nice.
Let's have a look at 14 here. Okay, so in 14 we have the object thrown into the air at 30 meters per second, 35 degrees to the horizontal. Okay, so they actually give us both the magnitude and the direction, okay, for that projected velocity, and we know it's going to do this. So this one's a pretty basic, pretty standard projected at an angle projectile motion problem. Okay, so we'll have our usual, this side is VI, this side is V horizontal. Okay, so vertically speaking, okay, we know A is negative 9.81 meters per second squared. Okay, we can calculate VI by going to sine of 35 times 30. Okay, so that's going to be 17.2, positive 17.2 meters per second. Since we're not told otherwise, we can assume impact and launch are level, negative 17.2 meters per second. Okay, and horizontally, all we can do right now is find V horizontal. So that'll be the cos of 35 times 30. Okay, so 24.57 meters per second. Okay, if I'm going to find out how far it travels horizontally, what else do I need? Time. Okay, can I get that with the vertical information? Pretty sure I can, right? Just use my good old Science 10 acceleration formula, VF minus VI over T, and just manipulate for T. All right, so that'll be negative 17.2 minus 17.2 divided by negative 9.81. Okay, so we're going to get 3.51 seconds. Okay, for the time, that can come over here. Okay, and then to get D, we'll just go V times T. So, times that. All right, and we're looking at 86, what do we have, 1 or 2 sig digs there? Sorry, 2 or 3 there. We had 3. So we are looking at 86.2 meters. Now, even if you're done this one, I want you to come back to this one because we haven't had a question that's asked you to do this for a while. I would like you to calculate the maximum height that that object will reach. Okay. Is there usually more than one way we can do that? Calculate the maximum height. Okay, we can usually, okay, use either this formula, as long as we remember to do what? If I'm finding the maximum height, when does it occur? Halfway through, so I gotta use only half the time. Or I can use this formula. Oh, not plus, equals. Okay, equals VI squared plus 2AD. I just have to remember that when it's at its maximum height, VF is 0. Okay, so either one of those will work. Okay, you can choose whichever way you want. Okay, and they'll both arrive at the same answer. Benefit of this one, you don't have to manipulate it, right? You just plug in here your 17.2, okay, times half the time, which is, what do we get for the time there? We got 3.51 seconds, so 1.75 seconds approximately, okay, plus 1/2 AT, so 1/2 times negative 9.81 times 1.75 squared, okay, and we should get around the same number. So I'm just going to actually divide this number in half so I have it. Okay, so I'm going to take my 17.2 with all the decimals, okay, and multiply it by that number, and then add that to 0.5 times negative 9.81 times that number again, squared. Okay, so it's going to reach a maximum height of 15.1 meters, according to that formula. Okay, with this formula, I have to manipulate, so it'll be VF squared minus VI squared over 2 times A. Okay, so for that, we're going to be looking at 0 minus the 17.2 squared, okay, divided by negative 19.62. Okay, got exactly the same, well, pretty close to the same number. Okay. Everybody all right with that? Okay. Now, the other day we were watching the video about Evel Knievel, actually Robbie Knievel, okay, and I found the video of Evel Knievel, okay, and that bus jump that I tell you, jumped all the buses and then he was like flying through the air. So I have that one. All right, so 15 is pretty tricky. There's several things on 15 that can make it difficult. And the first thing is that the ball rolls off like this. Now, the decline is here. This angle is 32 degrees because this angle is 32 degrees. Everybody with me there? Similar triangles? All right, so that means this side here is VI, and this side here is V horizontal. So it's the same triangle, it's just flipped upside down because this projectile isn't projected at an angle upwards, it's projected at an angle downwards. Which means that when I calculate VI, it's actually what? It's actually negative. This object starts in a downward direction, not an upward direction. Okay? So, I'm going to say here for my vertical information, obviously we know A is negative 9.81 meters per second squared, although since it doesn't change direction, we don't technically have to make it negative. And we know that the building is 9.0 meters tall, okay, and that this side here is 22 meters per second. Now, this is the trick with this one. You actually need to do it in 2 steps. Okay, so we're going to have first the sine of 32 degrees times 22. There's our VI, 11.66 meters per second, but negative. Now, VI and VF are not equal here, would you agree? Right? It doesn't come up and then come back down, so VF is some other number. But if I'm going to calculate how far from the base of the building it travels, that's the horizontal distance, I need to know how long it's traveling for, agreed? Okay, so what a lot of people do is they're like, oh yeah, well I can use this formula right now. Except, what did I tell you you'd never have to do with that formula if VI wasn't 0?
Calculate time.
Right. So there's another way to do this. Can I calculate VF right now? Yes. If I have VF, can I use this formula to get time? I can. So I'm going to take this formula out. I'm not going to use it. And I'm going to use this formula instead. Okay? I'll use that to get VF. And then I'll plug VF into here to get time. And then I can find what the horizontal distance is. Okay? Obviously, I haven't found V horizontal yet either. All right, so VF is going to be the square root of 11.65 squared plus 2 times 9.81 times 9 meters. I'm just going to make all of those positive. Otherwise, I have to make them all negative, so I'm just going to make them all positive. Okay, so there's VF, 17.67 meters per second. Okay, I'm going to plug that in and solve for T. All right, so T is going to be that number there minus that number there divided by 9.81. Okay, so this thing's only in the air for 0.61 seconds, which is not very long. Okay, and then I can use that with my horizontal information. Now, I forgot to calculate B horizontal, right? So we'll just quickly do that. Cos of 32 times 22. Okay, and then I'm simply going to multiply that by the time. Okay, so it should land 11 meters from the base of the cliff, or building, whatever it was. Okay, would I give you one like that on a test? No. On a unit exam, the questions I would give you would be pretty standard ones. Nothing saying I couldn't throw you a curveball on a quiz, though. That could happen. Yeah. Yeah, there's some multiple choice and there's some problem solving.
Oh, right.
Yeah. We'll talk about it on Monday when we do the formal unit exam review. Okay, good work today, guys.
Social